Okay, hello everybody. I'm here to talk about Suricata 8, which is the latest release from the team at OISF. So in today's presentation, I'm going to dive into it, which, like all our releases, it was a collaborative effort between the OISF and our community. Suricata is an open source project. As you heard earlier, it's been around for about 15 years. So Kelly spoke about the project earlier and some of its genesis. I'm going to try not to duplicate anything she said, but if I do, just bear in mind I prepared this for a different audience tomorrow. So for a brief historical note, Suricata is the genus name of the mercat. That's why we feature the mercats in our logo and all our branding material. And a group of mercats is referred to as a mob, hence the mob reference in the title. Mercats are known for their diligence in watching over their mob, and we think that Suricata performs the same function for organizations that use it throughout the world. Suricata 8 represents a significant step for us, and we remain committed, as always, to maintaining Suricata's position as a leading, relevant, and trusted open source network detection and analysis engine. Suricata 8 has been enhanced in a lot of ways. We have much better telemetry, maintainability has gone up. I'm going to talk a little bit about the extensibility part of it, which we're excited about. And like all our releases, performance just gets better and better. So just a little bit about me. Again, Jeff Lucovsky. I've been with the OISF team for 6.5 years. I've always had an interest in operating systems and security, and previously I worked on DoD-capable systems. And that low-level type of work has given me a passion for networks and network security. I also found out that I truly love working on open source projects, and it's mostly because of the community interaction. It's amazing that I can speak with somebody in Germany who's using our product for their very niche marketplace, and then at the same time provide contributions that might help somebody on some other continent. So it's truly rewarding work, and if you want to talk about that afterwards, I'd be happy to. So a long time ago, there was only proprietary security solutions available, and I've worked on some of those. But later, open source projects emerged, and Suricata was one of them. Suricata has grown and improved significantly since its early days before 2010. And I was fortunate enough to join this team in early 2019. You also see I have another title there. I am employed at Corelight, where I'm responsible for delivering Suricata on our physical and virtual sensors, as well as performance engineering. And I have first-hand knowledge of seeing how Suricata can scale and produce reliable, consistent alerts at anywhere from 2 gigabits to 200 gigabits and beyond. It truly is a scalable network solution in all sense of the word. So there's my contact information. Like I said, feel free to introduce yourself to afterwards, and we can talk about Suricata if you like. I'm going to briefly talk about the OISF since Kelly has already covered it. It's a US nonprofit organization formed to make sure that Suricata remains open source, accessible to the community, and free from commercialization. We rely on our, since we're a nonprofit, our cash comes from donations from security organizations throughout the world through the consortium memberships that Kelly mentioned. There's a lot of information at oisf.net. Feel free to look it up. It gives more about our mission, who we are, and what we've been doing. Okay, Suricata 8, obviously our 8th major release. A ton of work went into it. We delivered Suricata 7 in July 2023. Before Suricata 7, our release cadence was a bit off. COVID didn't help any, and we felt like we should not put out a major release while the world was in the pandemic. we didn't want to place that burden on anybody to have to do an upgrade during those times. So we relaxed and lengthened the amount of time that Suricata 6 was available. But moving forward, we have other objectives. We want to do major releases every 2 years and support every release for 3 years. And if you sketch it out in your head, you'll see that there's 1 year of overlap, and we want to use that 1 year of overlap to help folks move from the old release to the new release. And our other goal is to deliver security patches and bug fixes to both releases that we're supporting at any one time, several times per year. So, Suricata 8, 2 years of development. You can see some of the statistics there. One of the interesting things that you may not see immediately is that we continue to shift towards Rust. Rust in our practice has superior in every way. C is great, Rust is better. And we're trying to move everything that handles untrusted data, like our application protocol parsers, from C to Rust. And we'll talk about this a little bit later. Our documentation continues to get better. We realize that it's not perfect, but we are actively making sure that anything that new that goes in or changed is documented. And as we find places that need existing things that have not changed, we try and improve those as well. Suricata 8 release announcements, we typically do that on our suricata.io page, which is a great landing page to learn about anything Suricata related. I just want to take a brief moment. Kelly talked a lot about community, and this slide and the next slide kind of demonstrates what that really means. So you're seeing information from a leaderboard. We can't tell you how much we actually appreciate our community and the contributions that they make to Suricata. And so to acknowledge these, we have leaderboards that quantify the organizations that contribute to Suricata and the individuals that do that. You can see there's a score that's in place, and the score is kind of based on how much effort was the change that you made. It's not meant to be competitive. It's meant more of a lighthearted way just to show the relative contributions between different people, but not actually measure them against each other nor the organization. So Victor Julian, our technical lead, set this up as a way to record what happens when, and if you go to that URL on the bottom and take the 8 off, you can see we have leaderboards for current work and our past releases. So the previous slide was the organizations, here's the individuals. Eric LeBond is a renowned figure in the Suricata community. He was one of the very first developers that joined Victor and William Metcalf and Matt Yonkman to help us get started. He continues to make significant contributions, even though he's the CTO of Stamus Networks, which is more than a full-time job, but he finds ways to make Suricata better throughout that. Number 2 is a longtime contributor to Suricata, a member of the community. We appreciate his. I want to touch on number 3, because that's really important. Kelly mentioned Outreachy before, and how organizations can use Outreachies to give interns a leg up, and so to speak. And so number 3 is an intern who worked with us a year ago for a 3-month period, and she made significant contributions during that time. So in case you're wondering, can you get value out of Outreachy interns in your organization? The answer is absolutely. Okay. So I know that some of you have used Suricata. I know it's deployed with Security Onion, but I wanted to give those who aren't familiar with it just a little picture that kind of demonstrates where Suricata can fit in and how it can be used. Most organizations tend to position Suricata to get network visibility in an area of their network based on what they want to see. So in this diagram, Suricata is getting network packets off of a tap or a span. And it has visibility to those things that are on the right and what's on the left. So this is a north-south deployment. It sees internet to intranet traffic. Many organizations also find it useful to monitor their strictly east-west traffic, which is traffic within an organization. The characteristics of north-south versus east-west are very different. And some of the rule sets that are accompany Suricata are geared towards east-west traffic or geared towards north-south traffic. What this picture doesn't show is the component that actually makes Suricata, one of the leading detection engines, and that's the rule set. A rule set is a collection of directives that tell Suricata what traffic to watch, and for that traffic, what characteristics should be alerted on. Suricata simply applies the rules, but it does so in a way that is efficient and scalable and provides value to the customer. So we have a lot of ways to write rules. There's a lot of people with those skills. Most folks tend to use rule sets from ET, which is Emerging Threats, now owned by Proofpoint. So it's often referred to as ET/Proofpoint. They have paid and free versions of the rule sets. Suricata can also generate rich metadata based on the traffic that it sees. So not only will an alert have a lot of context about this is everything I know about those connections, but the logs that aren't associated with the alert also contain a lot of metadata that tell you what's going on on your network. So Suricata is a visibility engine as well as a detection engine. All right. So I'm going to talk about some of the new features in Suricata 8, and then for each of these, I'll go into a little more detail later in the presentation. So I've already mentioned Rust. We have more Rust. We have less C. We're about a 75-25 split, with 25 representing Rust. Rust is a language that provides a lot more guarantees than C can provide. It's very much hardened and very suitable for our application. It's incredibly fast, has low overhead, and it works well with helping us solve the types of problems that we're wanting to. In this version 8, we converted a HTTP protocol handling library, which if you know the HTTP protocol, you know that's not a simple thing. It was all done at C. However, one of our community members, with help from some of the OISF staff, took it upon himself to take the C implementation, convert it to Rust, and then we've now incorporated that into the Suricata code base. So we feel that gives us a number of advantages. It hardens a place that was not hardened, as well as bringing all the other improvements with Rust to it. So detection and logging are two of the core functions of Suricata. So detection is the ability to recognize malicious activity, and logging is the ability to take what you see on the network and represent it in logs in some form. So sometimes we call that metadata, sometimes we call it logs, but it's all the same thing. It's Suricata's view of what's happening on the network with detections thrown in. So when I talk about protocols, some of these protocols are detection and logging. They do both, and we have a couple of protocols that are logging only. So we will provide metadata for those protocols, but we don't have the ability to do any detection yet on those. So new protocols include DNS over HTTP2. It's called DOH. LDAP, which you probably have heard of. Multicast DNS, which is used in a lot of cases, but not as widespread as DNS, WebSockets, and then SIP, the Session Initiation Protocol. We've always supported over UDP, and now we support it over TCP. The two logging-only protocols that I mentioned are POP3 and ARP. Both important, but not covered before. I mentioned Lua because Lua we think is going to be a very powerful add to Suricata. Previously, it was always optional. And Lua is a way that gives rule writers the ability to embody their rules with a pragmatic angle to it. So you can have a workflow while you're doing a rule evaluation, and then you can invoke a Lua script to do something dynamic perhaps. So Lua can be really powerful. What you can do with Lua is based on your skill with Lua. Lua is a programming language that has been around for a long time. Now we've made it a mandatory part of Suricata, so it's always there. Rule writers can depend on it. We've selected a specific version of Lua, so there's a known feature set, and as we move forward, we'll make sure that whatever we do is backwards compatible. Suricata is a library. That's the extensibility part that I mentioned before. This is something that has been a request from the community for some time, and it's been coming together in pieces. And Suricata 8 is where we think it's ready for others to consume. So it's always been consumed by the particular community members that brought it to our attention, but now it's even better and it's ready for more widespread use. And if you're wondering why would I ever want to do Suricata as a library, if you consider environments where there is already a packet handling framework, there's already a routing framework for the packets and whatnot, and you just want to know, do I need to worry about this particular packet? That's where Suricata comes in. So you can initialize it, you provide it in your runtime environment, and you can give it the packet stream that you want, and it will tell you whether or not there's any alerts that you should be aware of with that packet. And then the infrastructure that's doing the packet handling can decide what to do with those packets, either drop them or not. But it's a way for vendors who already have an in, think like a Cisco switch or something, where they already have the packet handling, and now they want to enable Suricata. Suricata, without the Suricata as a library part, does everything from A to Z. It will pull the packets off the network capture device, do its analyzation, and generate the log output. Suricata as a library skips the packet capture part, just as the detection part. Another thing that we feel is important that we hope will gain some traction is what we call bidirectional rules or transaction rules. That's instead of having two rules that say, I want to match, like this HTTP header and this HTTP status code. You might do that in two separate rules. One's for an HTTP request and one's for an HTTP response. With the bidirectional rule support, you can have one rule that does both. So you can say, generate an alert if the HTTP request looks like this, and maybe the HTTP response is, 302. I'm just making something up. But you can have one rule do that. So there's state that's maintained, and we call that a transactional rule because it's part of the HTTP protocol transition. We've also added 107 new rule keywords, and I'll talk about that in a little bit. Those rule keyword is something that you can express in a rule. Later on, I have an example of what a Suricata rule looks like, and I'll point out what the keyword is. Okay, more new things. The first one is really important, and I hope I can do it justice, but data sets within a Suricata context are a way of maintaining a list of data, such as a list of suspicious DNS domains, IP addresses that you either want to whitelist or blacklist. Anything else that can be expressed in list form can be used as a data set within a Suricata rule. So the exciting part of this is now we have contextual data sets. So you can have your item of information, say, some badhost.org, and to the right, you can have context that's associated with it, such as maybe the campaign in which you noticed this suspicious domain, or the date that you saw it, or maybe the date first seen or the date last seen, or something like that. So the context comes into play when there's an alert generated on that data set item. It will show up in the alert, and it'll have the additional context so the incident responder has more information. Firewall mode is brand new in Suricata 8, and everybody knows or has a good idea of what a firewall is, and now Suricata can act as a firewall. I'll talk about that more in a separate slide, but you can have Suricata acting as Suricata as an inline device, which we call intrusion prevention system, IPS, and you can have it also act as a firewall. And one of our consortium members has publicly stated that this is what they intend to use in their firewall product. and I'll talk about that consortium member in a minute. We also added something that makes it easier to deploy Suricata. Suricata is a high-speed packet processing engine, and if you've ever done packet processing at network speeds, you'll know what I'm talking about. It has to be fast. It can't tolerate latency. And the way that you usually make these things all work is you very carefully align the system resources with the Suricata resources. Auto-pinning is a way of doing that alignment automatically. So you can deploy it on one platform, you can deploy it on another platform, and Suricata will lay itself out on that hardware to optimize performance. You can still specify things manually, but we think that this automatic assignment will apply for a lot of people. Performance, as I mentioned, throughout Suricata, it's just better. So performance is better, latency is reduced. We have a long ways to go because performance is a series of 1,000 baby steps or more, but we're making progress. Statistics are really important, particularly when you're managing lots of sensors and you want to know what happened. So we have added statistics. We've made them, we've clarified them in cases where they've needed to be clarified, and we've added additional and categorized some of them differently to give you greater insight into what's going on. Output is the metadata or logging that I've talked about. We have richer logs now. Richer logs means better forensic capability. Okay, and this is the, yeah. So from a from a security perspective, we like to include Rust. libHTTP is our HTTP protocol library that is now exclusively in Rust. FTP is an application layer parser that we are in the process of converting to Rust. So major foundational pieces of it have been converted to Rust. Some of it's still in C, but we're making progress. ENIP, Ethernet over IP, is a protocol that, that has a fair amount of use. That's been added to our Rust library, and we've taken MIME parsing from a C-based implementation into Rust. An application layer parser is what enables Suricata to understand and digest higher level protocols. So these are the list of the new protocols in Suricata 8 that I talked about a little while ago. Suricata now has 30 application layer protocols that it understands. Part of the extensibility is we now make it possible for a third party to take Suricata and write their own application layer parser. Perhaps they have an ICS protocol that is not widely used outside of a very small user base. They can do that, or perhaps they have their own proprietary protocol that they don't want to divulge the details on. They can write it, Suricata will load it and support it, and then pass traffic to that application layer parser so they can do whatever they need to do with it. Let's see. Okay, that's it. SDP, in case you're wondering, I had to look that up, is a session description protocol. It's a protocol built on top of SIP. Just a little bit of trivia, I didn't realize that it was, but we now have a parser for that. Okay, I'm going to talk a little more about Lua here. So Lua is a programming language. It's kind of looks like it's a compiled language, but it kind of looks like Python in some ways. It's pretty easy to write Lua code once you understand some of the basics, but it's not a very complex language. But we have made it so that Lua 5.4 is vendored into Suricata, and like I said, that gives rule writers a steady target. So it's always there. Previously, they had to guess, is Lua there? What version's there? Do they have this particular feature of Lua or not? So we took all the guesswork out of that, decided to vendor it in to launch the capabilities of Lua and provide them for whatever your rule detection demands are. You can do it now. So We realized that we didn't want to just put this in and then not have any guardrails. So we run anything Lua related in a sandbox environment. So those are our guardrails. We guard execution time, memory usage, and other things like that to make sure that it can't take down the system. Lua scripting can be used in any rule. All of our, the interface that we have is we have something called a match function. Matches that say yes means that rule evaluation should continue. If the match says there is no match here, then that means the rule evaluation is terminated. We leave that up to the Lua writer as to what determines a match or not. And that's under their control. So they can have, custom programmatic rule detection. It could be dynamic if they wish for it to be. We've also taken Lua and added to what's known as a Suricata transform. A Suricata transform is something that receives an input buffer, performs some transformation, and then supplies that input buffer, or that modified input buffer, to the rest of the rule evaluation chain. That's called a transform. We've made it so that you can have a Lua script provide this. I recently wrote a transform for some other work that I'm doing that took in an IP source address, converted it to what its CIDR representation was, and then exported that, and then I checked to see if that value is in the data set. So Suricata doesn't natively support that, but it indirectly does because I can use Lua in the transform part to take the input, convert it to what I want, and then use it in the output. Suricata as a library. I mentioned the environments in which it's helpful, but it's bringing your packet infrastructure, your threading infrastructure, and then invoking Suricata to have it make that decision for you. Does this packet cause an alert to be generated? When Suricata makes that decision, it will take into account the type of packet, and if it's part of a TCP transaction, it will do the reassembly, put it into the TCP stream, and then apply the rules across the entirety of that stream. So giving it a packet and getting an alert out of it can be really simple, but most rules are written around HTTP or DNS or even TCP, and all of those are stream-based, and they all involve some sort of reassembly. So Suricata internally is doing that so it can represent the stream, so it can do its detection capability. It's a work in progress, but this is the first release that we're using it. The folks that initiated the request are actively using it in their own environments, and based on their feedback, community feedback, and things that we find, we are also extending it. The Suricata source repo has examples of how you might use Suricata as a library. They're very simplistic, but they demonstrate the idea. Basically, it involves an initialization step, packet capture, using Suricata, and then when you're done, doing some cleanup. Okay, so a transactional rule is something that I mentioned before. I'm going to stop there for a second and go to what the rule is. This may be the first time that some of you have seen a Suricata rule, so I'm going to explain the major parts of it and then go back to the top. Every rule begins with an action when it is in IDS mode. That is, it's receiving a tap. It's in passive mode, so it can't affect the traffic flow. The first word is what to do when you see traffic that matches based on things to the right of that. Alert is the only noun, only verb that we can have for IDS, but if this were an IPS, it could be something like drop, or it could be reject, or it could be bypass to say this traffic is okay, I don't want to see it anymore. So the first word is saying generate an alert if the rest of the rule matches. And the rest of the rule means it has to be, only apply this rule to HTTP streams. Any and any are the source specifiers, so you can specify a network IP address, you can specify a CIDR, you can specify a list of either. The second any refers to a port, so again, it could be a list of ports, it could be any port except this one, or it could be the word any. The arrow indicates the traffic direction flow, so from the source address to the IP address. There's also a bidirectional designator, which I think is this, the equal greater than. Normally it's greater than, less than greater than. Any are the target IP address, and then whatever's in the parentheses is the criteria to determine whether or not an alert will happen. In this case, it's saying if I get any file object, so like an HTTP post will have with it an associated file object that's flowing towards the server, and it just happens to have the content 123 in it. So that's the request part. The response part of this is if the HTTP status code from the server is 500, then generate an alert. We could ignore fast pattern for now. That's an optimization hint for Suricata. But this is a bidirectional rule that combines an HTTP request with an HTTP response. Those are the relevant parts of the rule that apply to each. Suricata 8 allows this to happen, so they'll be a little bit more efficient and another way to express a rule writer's ideas of how to generate an alert. Okay, so Suricata 8 has a lot of rule keyword additions. In the rule that's shown here, ftp.reply is a rule keyword. It tells Suricata what the data object is and what the value should be. As part of Suricata 8, we decided that if you can log it, you should be able to detect on it. So log and detect. So we got this list by looking at the logs that we generated, and then based on community feedback, we made a prioritized list of things to add. FTP was one of those things that was requested by some of the rule writers at Proofpoint. And so we spent some time on there. All in total, we did 107 new keywords based on community feedback and things that we thought were important. With Suricata, you can run it. If you can run from the command line, you can use that special option, list keywords equal all. You can see that. You can also specify a regular expression and use like FTP if you just want to see the FTP-related keywords. But like I said, we added 107. Which is a significant increase in the number of keywords from the previous release. This rule example shows FTP reply, which is one of the new ones. And this rule will generate an alert if an FTP reply contains the content, please specify the password. And if you know the FTP protocol, you know that this rule has little value because FTP replies, that's common to see that. But you can specify other things there that are uncommon. There's other FTP keywords. We list them on the command line if you run that option. They're also on our online documentation. Continuing with rules and detection. There's a few more. TCP, that's I think the window scaling factor. The other one relates to Postgres. There's multicast DNS. Not really sure what ALPN is, and then we have WebSocket support. We also added a new keyword called entropy. And for those of you who are involved in threat detection, you may recognize that higher entropy is often associated with malicious data. So Suricata can evaluate the entropy of any content that you want it to, say content as part of an HTTP post or an HTTP response or whatever it might be. And then Suricata will calculate the entropy value for that data, and you could specify at what level you're concerned with. 0 means low entropy, 8 means the highest entropy. It uses a common entropy algorithm for making its determination. It's not something that we made up. And you can use that as part of your rule evaluation. So again, higher entropy values have been found to be more often associated with malicious content. The datasets upgrade I mentioned was really important because of contextual alerts and the framework that it gives. This is an example of a snippet from an alert that uses data from a data set. So think of it as an annotation to a value. but it can be rich value in the format that you want it to be in. So you just supply JSON, and we'll include that JSON in the alert, and that gives you greater context. So this one lists something that, this is an example, but this gives the kind of context that you can include in an alert that will save the incident responder time so they can do better triage, and they may know why is an alert being generated for this, and the context is meant to show that. So, as I said, you can list anything. Things that are important might be the campaign, where it was discovered, when it was first discovered, how often it's been seen, when it might not be of interest, or when this might expire. Suricata firewall mode. Okay, yeah, I see I list the vendor that uses it. So Suricata it's a new mode for us. It's supported. It's not yet done, but it's pretty close to being done. So Suricata can now be deployed as an IDS, which is that passive intrusion detection system, reading a tap span, can affect traffic. You can deploy Suricata inline mode, so it takes packets from one side, performs Suricata-specific actions on it, and then delivers it to the other side if it meets all the criteria. Suricata can now act as a firewall. I think everybody is probably familiar with the firewall concept. It's simply deny all traffic unless it's explicitly accepted. But you can combine Suricata in firewall mode with Suricata in inline mode, or intrusion prevention system. That's where we can apply the Suricata rules that are common, that you already know about, on top of Suricata acting as a firewall, and they behave exactly how you would expect them. So only traffic that the firewall permits is evaluated by Suricata's detection engine. And yeah, AWS is using this. This is their network firewall. The other modes of operation, NSM, network security monitoring, generating logs, generating metadata. Does this in kind of the same way that Zeek generates its logs. So using Zeek and Suricata together, you can combine the powers of both. Zeek has its own sets of pros and cons, but Suricata is a full-fledged, fully capable generator of metadata, of rich metadata. It does it different than Zeek, but the end result is the same. It provides mountains of forensic data for incident responders and threat detectors. A little known feature of Suricata is it can do full PCAP capture. In Suricata 7, we introduced, again from Eric LeBond, what's called conditional PCAP capture. That says if there's an alert that involves this data, then generate a PCAP of the data involved in the alert for better forensics. And they can be combined in various ways. CPU Infinity, that's the auto-pinning feature I talked with. We added 2 ways to do this. One is by associating CPU information with a network interface card. And when I talked about high performance and low latency, associating specific CPUs on a multi-socket device with a specific network interface reduces latency and increases efficiency. And there's a lot of technical reasons why. One of them is NUMA. It's kind of a deep dive in its own set of interesting, but we now allow you to make those kind of specifications. We can also do it at another level, just a little bit higher level. You can say, hey, Suricata, you know how many workers you're going to deploy. You know what my CPU layout architecture is. You know what the NUMA nodes are. Just give me the best, your best guess at how things are going to be laid out. And it will make the right decision. All right. I mentioned performance improvements. So throughout Suricata, that's one of our guide marks. We do performance testing all the time. It's part of our CI process. Any anomalies are flagged and are a reason to subject the PR to greater scrutiny or perhaps rework. But there's also something that we did, which I've seen firsthand at Corelight, and that is the initial start time for Suricata. So when Suricata first comes up, it will have these rule sets from ET Pro and elsewhere that it can have 70,000, 80,000 rules. And that's, I did say 70,000 to 80,000 rules. That's a lot of rules to process. And it takes Suricata a fair amount of time because it has to apply its analysis and its processing to each and every rule. That takes a couple of minutes. So it's not a long time, but it is a long time if you're trying to deploy a highly available, network detection engine on your network. What we've done in Suricata 8 is cache things. So things that need to be changed are changed, but the things that don't need to be changed aren't changed. So what that means for a rule is if the rule is like it was before, and that happens for the majority of rules, Suricata can start in a few seconds. The first time I actually witnessed this, I thought there was something wrong with my Suricata deployment because I'm like, wait a minute, it can't start that quick. And then I said, oh yeah, we do rule caching, and that's the effect. So in highly available situations that may be running across your network, processing high traffic, having Suricata, restart is, maybe for administrative reasons, for having it, start again and once starting processing traffic, only missing a few seconds of data is much better than missing a minute or two. So on a high-speed network, that can be a lot of data. Suricata has always been a rich network security monitor. It's even better now. So we have more logging output. We have richer logs. All the new protocols have all their logging. Most of those also do detection. I mentioned statistics outputs before. An exception policy is what Suricata, you tell Suricata what should it do if something goes wrong. And now we have better statistics to help you understand what actually happened and what category of something went wrong did with our statistics. Memcap and memuse are related. Suricata, unlike some other network products, Suricata will self-regulate its memory usage. A memcap is a memory cap. It's a limit on how much memory Suricata can use. Memuse is how much memory Suricata is using, and we divide that among several categories, and they're very important values. You could supply a really low value to memcap, and Suricata is saying, hey, I want to process this packet, but you've given me an artificially low number for Suricata, or for TCP reassembly, so I can't do anything with it, so I'm going to be dropping this. But it also gives you guardrails. It prevents somebody from taking over your system just by injecting a lot of traffic. I have firsthand knowledge of other security products that will happily ingest any network traffic they have and just wait for the system to terminate them with an out-of-memory exception. That really happens. It's very rare with Suricata, and if it does, it usually means there's a configuration change that needs to be made, and then things will work better. Eve schema. Eve is our extensible event output format. So everything gets, we talk about Eve and output almost in the same sentence, but we schematized our output. And that's important because that now allows consumers of our output to have a schema against which the data can be evaluated. And we are diligent about this. Our end-to-end tests that we use in-house, one of them is called Suricata Verify, which is an end-to-end test utility that we wrote. Part of the steps of Suricata Verify is to make sure that any output generated is represented in the schema, and the test will fail if it's not. So we are very confident that we have our entire output schematized, and that's really rich. I am at the end of my talk, so I'm going to quickly go through more resources, leave them up in case you want to take a photo. Suricata.io should be your landing page for all things related to Suricata. From there, you can get to everything else. Awesome Suricata links is not something that we put together, but one of our community members did. It has a lot of information, a lot of links to various things that you'll find important. We, the Suricata team, actively participate in our forum, forum.suricata.io. These two links talk about the 8.0 release and whatnot, but if you go to the forum and post a question, you'll see that it's all categorized. You can post questions, and one of the team members will usually get back to you within a few days. So I recommend, if you want to learn more, go to suricata.io for your landing. Of course, we're on GitHub. Our repositories are there. Our Suricata Verify test repository is there. Discourse is where we host our forum. Discord, We also we tend to use it a lot during Suricata, which is usually always in the month of November. And then there's a place on suricata.io where you can sign up for our newsletter. I just want to take a moment and pause that that area in the orange block is really important. And we, the OISF team, we truly believe that it's because of the community and the input that we give and the interactions that we have that Suricata has come to where it is. It really does support mission critical operations all over the world, and that's great, but it has a vibrant community, and that's even better. I mentioned Suricata, which is our annual users conference. This year it's in Montreal. It's in November, the week just before Thanksgiving. That's where people who are well into Suricata or who want to learn more about Suricata or deploy Suricata come. We see a mixture of developers, of people doing threat detection and incident response, and also system integrators come. It's a 3-day conference, a lot of signal, very little noise. This year it's in Montreal, and as Kelly mentioned, we have a couple of passes to pass out. Okay, this will be my last slide because we're just about out of time, and I'll take some questions. But if you want to get involved, contribute. We don't need everybody to submit code submissions. You could also look at our documentation and proofread it. Yes, we have grammar errors in our documentation, things that are easily fixable. We also have things that probably aren't as clear as they should be. So we welcome contributions in any way. Use it, read about it. If you find a problem, use our forums, let us know about it. Use our forums, you can engage, ask questions, share things you've learned, ask questions about, hey, can Suricata do this? If you are technically skilled and you have expertise in a coding area that we cover, feel free to contribute. We welcome that. We're not an angry bunch. It takes a long time for me to get a PR through. And if it takes you a long time to get a PR through, that's not a reflection on you. It's just a reflection on the steps that we have to go through to make sure that something is accepted. I had one PR that was open for 1.5 years, but I kept at it. It kept getting better, and then it finally got accepted. So it's not a rejection in any form. It's a, hey, this is good, but can we make it a little bit better? That's everything. Any questions?
So in regards to like Suricata reading PCAP, how many layers down can it actually read?
So Suricata doesn't really there's a part Suricata depends on where is it getting the packet from. But all packets are expected to be layer 2 frames. So it'll start decoding it based on the Ethernet information, on the MAC information. And then it will take it through all of the steps that are involved. So it could just be an ICMP packet, very simple to decode, or it could be TLS or some higher level application like SIP. So the part of Suricata that fetches the packet and the part that decodes it are distinct. And so the only part that's different in this workflow is how did I get the packet? Oh, I got it from a PCAP file. But as long as it's a layer 2 frame with a known ether type, we'll flag it if it's an unknown ether type. We'll start decoding it right away. So if it looks like IP, we'll go ahead and process the IP. If IP says, hey, this is a TCP packet, we'll continue in TCP or vector into UDP or whatnot. But everything goes through the same inspection as far as necessary to decode it. We might generate events along the way and say, hey, you told me this is an IP packet, but it should be this long, but it's too short. Or it has something else that might conflict with it. If it's a VLAN packet and it doesn't, and the header's not big enough, we'll flag that and say, well, we can't do anything else with this.
I have one more question. So for like job 4 for TLS and SSL, does Suricata support job 4 hatches?
Job 4, yes. Job 4 plus, no. So we will recognize, and you can log JA4 or JA3. You can log JA4 hashes. I believe we have some detection capability on that, but we do not in any way support Job 4 plus because of the licenses and the other requirements around that. Doesn't mean you can't take Suricata, and if you have an agreement with, to use JAW4 Plus, do your own thing, but we can't supply that because it is licensed and protected. Okay.
Using Suricata as a PCAP capture engine, does Suricata also provide facilities to read that PCAP so they can give it a PDF expression and then search the PCAP and then find that conversation and answer that expression for you?
Yeah. So Suricata can generate PCAPs based on the traffic that it receives, and it can do it conditionally if there's an alert. And that's one way. So you can run Suricata in live mode, and it will pull traffic off your network interfaces or whatnot. But you can also run Suricata and say, hey, I want to read this PCAP file, or I want to read from this directory which contains PCAPs. And whether or not Suricata generated them or not, it will subject them to the same process and analysis that it always has. Suricata, it's a good question about the BPF, Berkeley Packet Filter. You can specify the hosts that you want to see or the protocols that you want to see or any other characteristics supported by BPF. So you can say, Suricata, read this PCAP file, and by the way, apply this BPF, this Berkeley Packet Filter, to determine whether or not you're going to actually process it. So it will read the packet, apply the filter. If the filter says continue with it, then it will. So you can narrow things down. So when I do my day-to-day development work, I have a collection of PCAPs, as do most of the team, and that's how I run Suricata. It's like, here's my PCAP directory, or here's my specific PCAP file that contains some malware that I want to make sure that I alert on and recognize properly, and also log properly. So good question. Okay, that looks like it's it. Thank you all.